All right, I can't wait too much longer, so we'll go ahead and get started. Everybody, thanks for coming. We're going to jump right in. I'm going to try to cover two routes. There's not going to be a whole lot of emphasis tonight on the scenario as a whole, meaning all the properties that we're concerned with when it comes to decision making. So be aware of the fact that we're really only addressing the primary concern of aviation weather. There's still lots of other things to talk about, but with the focus being on weather, that's what we're really going to hit hard on. We're not going to go too heavily into risk management when it comes to that, as far as trying to be very systematic when it comes to the risk associated with weather, but nonetheless, we'll at least talk about that a little bit. Give me just 1 second. All right, sorry about that. So let's go ahead and jump in. Tonight, we're going to work on learning weather tools available to us, learn the dynamics of weather behavior, and develop skills to make good decisions. This is actually from the Joseph T. Now report from 2016. This is just a sample of a couple of different categories where we see accidents by type. And you can see that from a weather standpoint, it's low in its total, but as you'll see, unfortunately, it's kind of high on the lethality standpoint. So if we do a comparison, we can see of those 23 accidents, 12 were fatal when it came to weather. So if we do a percentage calculation, you can see landing, while again it was quite high with the total amount, the total lethality rate is quite low at 1.8%, as opposed to, say, weather or even fuel management. Weather, though, kind of obvious. If you have an accident related to weather, it's quite high in its rate of lethality. In other words, basically for every 2 weather-related accidents, 1 is going to be fatal. So that's quite significant. You know, a lot of people, again, we kind of focus on landings, but the good news is it's quite low likelihood of it having a lethal property when it comes to the accident itself. All right, so one of the complications when we start to get into full weather briefings and trying to completely understand everything going on in the flight is the amount of information that we get thrown at us. And the problem, of course, with that is when we get information overload, we certainly have a problem with the fact that we struggle with making decisions and, of course, differentiating what information is pertinent, what information is less pertinent, and what information doesn't really apply whatsoever. There's one solution to this, and that is experience, and experience with repetition. So in other words, really for us, it's looking at lots of different scenarios and seeing the same types of information associated with different circumstances. But especially so if we look at different scenarios in relation to especially routes. So we're going to look at 2 routes tonight. The first one we're going to look at is a flight from the New Orleans area to Oklahoma, specifically in this case in a particular airplane, be a Cirrus SR-22. Our second route is going to be from the Nashville area to Asheville. So from Nashville, Tennessee to Asheville, North Carolina. So before we go any further on the slides, let's actually jump in to I've actually got the wrong one up here, so bear with me just a second. So to simplify things, we're not going to talk much about altering a route. We're just looking at a direct route. Our main focus, of course, is the weather associated with this route. Just a quick jump into the details, though. We can see at the top there, our distance is just about 500 miles straight line. In a Cirrus at 6,500 feet, we're expecting to fly en route approximately 2 hours, 48 minutes, closer to probably 3 hours in total if we fly direct, mind you. We're going to have a proposed departure time of 8 p.m. Eastern. So, of course, in the New Orleans area, that would be Central Time. So we're going to propose a 7 p.m. departure. To do this, many people may, of course, use ForeFlight. Irrespective, we're going to look at one briefing in ForeFlight. The other, we're going to look in Leidos, or flight service. So let's jump on Leidos. If anyone in here has no experience with this website, recommend you get on basically as soon as possible. So the base website is www.1800wxbrief.com. We'll head there. If you're using a tablet like I presently am, then you're going to be sent automatically to their mobile site. I recommend instead use the desktop website, which works fair enough even on a phone. To create a new account, you can see there's an option there in the top right hand corner. Well, it doesn't look like it works very well. It does that, does it? Irrespective, we'll skip that for now, and I'll just sign in real quick. From here, we're going to get a standard weather briefing for this route. These are just notices that they're making some changes that are quite significant. If you've gotten a weather briefing, anything less recent than I'd say in the past, say 2 weeks, you're going to see it's looking quite different in the way they present it. To get a weather briefing, we're going to go the fourth tab from the left under Flight Planning and Briefing, and I'll click on the top line, Briefings, Flight Plans, etc. Okay, so from here, we do need to use the ICAO flight plan format. That being said, we don't need to fill all of this information out to obtain our standard weather briefing. So from here, I'll select aircraft ID. We'll go 402 Charlie Bravo. Flight rules are going to be VFR. Flight type is a general aviation flight. Aircraft type, we can kind of see there is an SR-22. We're going to skip a lot of the specifics as far as aircraft equipment just to get to our main focus tonight, which is on the weather. Our departure, again, is going to be the New Orleans area. Our proposed departure time we'll put, again, here would be excuse me, 2:00 local, or 8 p.m. Eastern. Our cruising speed in this airplane would be approximately 178 knots. And because of this ICAO reference, we're going to put in an A, and then again our proposed, or at least expected for now, altitude be 6,500 feet. We're going to simplify things for the route of flight again with just leaving it as direct, and our destination again is KOKC. Elapsed time, just to make it nice and round, we'll put 3 hours. We don't really have a planned alternate at this point. We're just getting an initial picture on our weather. So for now, we'll leave that blank. Or perhaps maybe if we just had any idea, we could throw something in there. Let's say maybe it looks like turning southbound would be a better option. So we'll put in Dallas Fort Worth International, at least to have an idea of what the weather is like in that area. All right, let's see if I put everything in correct. We'll put in route brief at the bottom. If I didn't do something correct, then it lets me know. Oh, didn't put in cruising speed correct for ICAO. So anyone who hasn't put in a ICAO flight plan in, you have to do something extra. Even on top of this, you've got to put an N for knots, unless you're going to fly reference to Mach speed. And it's in thousands of knots, so it needs to be 0.178 in this case. And that should satisfy that requirement. Okay, with the new changes, they give you a whole lot of extra options. We can choose how wide the corridor is going to be along our route, as well as the winds aloft. Do we want to include graphics? Yeah, we certainly do. All the next gen content, so on and so forth. Briefing content filters. We're going to leave it pretty standard as it is, and then we'll have the option of either having the briefing emailed to us. We can set it to a PDF to save it, or just a standard web briefing. We'll do the web briefing. Okay, so again, if you haven't had a briefing from 1-800-WX Brief in a while, you're going to see things have changed in the way they present and format. Some things I really like. Irrespective, we just got all the base information at the top. And of course, as per usual, remember that whenever we get a standard briefing, the first thing they always start off with is adverse conditions. In addition to the adverse weather conditions, of course, there could also be adverse conditions in relation to, say, TFR. So starting out, we've got any notifications for temporary flight restrictions. This is quite nice because, of course, immediately you can see whether or not there are any complications along your route of flight when it comes to specifically TFRs. At least graphically, so it doesn't appear that there would be one along our route of flight that's an issue. They do give us the one there, 2934, which is the small TFR for former President George W. Bush, who lives in the Dallas area. So you can see that not only do we see it graphically, but we also see the textual TFR there as well. Now, is it satisfactory to just see the graphical depiction and therefore not need to read the text? It depends. The fact that this is so far out of the way, it wouldn't be an issue. But we also have a possible alternate diverting to the south where that suddenly could become an issue. So certainly if I intend that I might actually divert to the Dallas-Fort Worth area, I would benefit by not only just seeing where it is graphically, but also reviewing the information textually. Namely, it's not that large. We can see at the bottom, after it gives us all of the legalese and the fact that if you willfully or knowingly violate those rules, then of course you're subject to certain criminal penalties under that U.S. statute code there. But specifically, what is it? Well, we can see, unless you're authorized, it's a 1 nautical mile radius. And then, of course, they center it in that latitude or longitude or off of this VOR at that degree bearing off of the VOR. So in this case, 85 degrees at 4.8 miles, up to and including 1,500 feet. So it's a 1 nautical mile radius. It's 1,500 feet tall. Should certainly be circumnavigable at the worst case scenario. Other than that, we're not getting any notifications for closed or unsafe notices to airmen for runway closures or any other significant concerns in regards to that. Why is it not scrolling today? There we go. Okay, but the first thing that we do hit is we do have an advisory for an airmet, and we can see graphically where we penetrate that current airmet, and of course, in association, what is the concern? So on a progress check, specifically when we're talking about cross countries, we, as examining instructors, we're looking for you to, of course, understand the different types of weather products specifically, but also in association, their limitations. So let's say that I just jumped on here and I obtained this weather briefing and I'm really not sure exactly what an airmet is, much less specifically what an airmet, in this case, Sierra, is. There's a couple of ways, of course, that you can go about solving this. One, you can largely interpret a decent amount of information just by reading the text. So to start out, we can see that they give us kind of a plain language breakdown in the summary, as well as the validity time. So to start out, if we're just talking about the valid time, we can see the outlook for this airmet start is January 22nd at 0300 Zulu. That would be 2200 Eastern Standard Time, or about 9 p.m. in Central Time. certainly, and therefore, of course, could be a concern based off our planned departure. The end is not defined at this point. And of course, the concern is specifically for ceilings below 1,000 feet, visibilities below 3 statute miles, and precipitation and mist. They expect these conditions to continue through 0900 Zulu. So we already know that in AirMet, at least one of the types of AirMets is for IFR conditions, where conditions exist in at least ceilings below 1,000 feet and or visibilities below 3 statute miles. They give us an advisory, of course, warning, big red flags, excuse me, that this AirMet will be active while we fly through that area from those 2 time frames, from 0308 Zulu to 0351 Zulu. Specifically, then of course we can read the original product format here. We start off, of course, of where it's issued by. It's issued by the Aviation Weather Center in Kansas City, Missouri, on January 21st at 2045 Zulu, which would be 3:45 Eastern this afternoon. Specifically, this AirMet is for the Dallas-Fort Worth forecast area. What in the world does that mean? Bear in mind that when you see that, what you're really talking about is a large area covered based off of what we call a air route traffic control center. So there are air route traffic control centers across the country. When we talk about Jacksonville approach, Jacksonville Center or Jacksonville Air Route Traffic Control Center, that center goes all the way down to basically where we're at in Orlando, to well north into just about Virginia. So it covers a large swath of area. So even though we're not technically going to be flying in the Dallas-Fort Worth area, at least off our initial route, that still applies for that area. So it's an AirMet Sierra, and then of course it gives us the same preparation time. Specifically, this is an AirMet Sierra Update 5. So again, Sierra represents the fact that this is for IFR conditions, and this is the 5th update, specifically for IFR and possibly mountain obscuration as well. And then it gives us those same valid times, in this case valid until 0300 Zulu. That's of course important, because if you're trying to figure out what's going to be going on beyond that, you're going to need to determine that based off of a new product. After that, it also gives us an outlook estimate beyond that, and then it gives us a boundary. The boundary we don't care too much about, admittedly, because it's doing the same thing. Because the boundary is actually graphically depicted, and we'll see that kind of in its full picture here in a moment. But the way it bounds is based off of distance and bearings, or basically cardinal directions relative to different VORs. So this entire section here is basically drawing out a boundary. Again, you don't need to take your chart and plot that out. It's done for you. Again, the part that we primarily are concerned with, we see rather both in this kind of more detailed blowed up position as well as that one there. But in its holistic view, which we'll look at here in a little bit, we would see that area in its entirety. Again, don't necessarily need to plot that out. You just need to understand the way they plot it is based off of distances and bearings to ground-based navigation stations. And then they give you the conditions finally at the end. The ceiling is below 1,000 feet, and or visibility is below 3 statute miles, and precipitation and mist. Again, the conditions are continuing through 0900 Zulu as far as an expected outlook. Before we go on, where can I go to get more information about this? Well, you would go to a couple of different options. The first option, the first go-to, is the Pilot's Handbook of Aeronautical Knowledge. So we jump into the PHAK, or Pilot's Handbook of Aeronautical Knowledge. We can go to the table of contents. Excuse me. And let's find the chapter on weather. So we're scrolling through here. And then you get to chapter 12, which is weather theory, but specifically what we're talking about right now is a weather product. So we're less concerned with weather theory at the moment. We're more concerned with chapter 13, aviation weather services. So we'll scroll through here and see if we can't find anything about AirMets. Well, sure enough, in-flight weather advisories, chapter 13, page 11. So we could head to chapter 13. And scroll to page 11 here. And there's, of course, our information about airmets. The question you're absolutely guaranteed to be asked in one way or another on at least one of your progress checks, and the private certainly, but really any check ride, private, instrument, commercial, certainly CFI, is how often airmets issue. And in this case, you can see the first thing they tell us is they issue every 6 hours. Now, why do we care about that? Because if an airmet came out 3 hours ago, you know how long it is until the next airmet comes out. So in this particular situation, if you're sitting on the fence because you're like, well, can I beat that there? If I leave earlier or if I leave later, will things improve or deteriorate? If I'd like to wait to see which direction the weather is moving or whether it's going to deteriorate one way or another, I could wait until the next release comes out. And by knowing how often they come out, then of course you're more equipped to make that decision. Let's keep moving on. We've also got an airmet for icing, but notice no airmet for mountain obscuration because, of course, there shouldn't be any mountains around the Oklahoma area. Excuse me. So the next one we have is an airmet for icing. Yes, these also come out every 6 hours. We can see that it's graphically depicting just about the same location as the previous airmet was. So we're starting to already see a trend that even before we look at the big weather picture, it looks like there's a weather driver that's creating both IFR conditions and forecast icing conditions. Let's get some details because you can see that even though you fly into the graphically depicted area, when it comes to icing, we also, of course, certainly need altitudes for both the freezing level as well as they forecast icing to be potential. Good news, of course, is if you're flying VFR, if you stay out of visible moisture, then you shouldn't have to worry about icing. But if we look at the summary, excuse me, airmet start, same time frame, end is still also not defined, and it's forecasting moderate icing between freezing level, whatever that may be, it varies from place to place, and as high as flight level 240 or 24,000 feet. In this case, the freezing level ranges anywhere between 5 and 11,000 feet mean sea level. And considering my proposed en route altitude of 6,500 feet, I certainly could encounter those conditions. The conditions are also expected to continue beyond 0300 Zulu through 0900 Zulu. And then, of course, they give us the full rundown. Now, this looks intimidating. We talked about information overload. This is a good example of information overload. The best way to chew this off, of course, is to break it down. You always know that the first thing they're going to do is give you base information. Where it was disseminated from, when it was prepared, and, of course, what it is. So we can see it's an airmet Zulu specifically. So guess what? Airmet Zulus are for icing and freezing level conditions. They're going to give you a valid time. So, and you can see that the valid time pretty much looks the same as our previous airmet for the airmet Sierra. Then they give you a boundary. So they're doing that same thing. They're creating a boundary for the applicable area. It's just there's a multitude of areas, and that's why you see different shadings, is there's several different groups. The first group, they give you the boundary, and then they give you the conditions once again. So moderate icing between the freezing level and flight level 240. And again, the freezing level ranges between 5 and 11,000 feet with the conditions continuing beyond 0300 Zulu through 0900 Zulu. Excuse me. I have to get some water. Then they give you a new area, of course. Freezing level ranges from the surface to 14,000 feet mean sea level across area with multiple freezing levels existing anywhere from 4 to 11,000 feet within an area bounded, and then they give you another boundary. The biggest question is which one is which. That's the thing that I don't like about this new briefing is you can't select them individually. On the older briefing, I could tap on each individual shading and it would give me highlights and then highlight this text down at the bottom again, which is not scrolling. Boy, oh boy. Okay, there we go. And that would make it a little bit easier. So at this point, I don't have a good answer for you on this. This is something I'm going to actually write them about because I think they forgot to make it clear which bounded area is which. And without us, therefore, literally taking these bounded plotting areas and figuring them out ourselves, which we're not going to do, that would take up too much time. It's difficult to say exactly which is which. The point is, for now, we know for sure that we need to further investigate the likelihood of icing potential, basically starting as soon as halfway down our route of flight, and certainly by the time we get into our destination. So red flags, of course, are already going up about this proposed flight. Then we have an Airmen Outlook. In this case, excuse me, also certainly applicable. And once again, they give us that big red flag that this Airmen Outlook is certainly going to be active for our traversed area. They show it there, of course, in the depiction. I think I just figured it out, actually. Let's see. Yeah. Okay. So the more solid shading is your expected active air met, whereas the less heavily shaded, the lighter color, is your outlook, which is this one here. You can kind of see they have it depicted there. So the outlook is not conditions that you'd expect more immediately. There's certainly going to be conditions expected further out. So again, basically beyond 0300 Zulu up to 0900 Zulu, things don't change much. Still calling for moderate ice up to flight level 240, and the freezing levels ranging basically between the same altitude. So it really doesn't change much between what we expect to be up to 0300 Zulu and there beyond. Then we can see the actual freezing levels, and this is really what gives us insight specifically into what we think would be going on. Now, once again, a little bit of information overload. These charts have lines associated with different altitudes where we expect the freezing level to be. So for example, where we're at, we can see that we're basically halfway between two blue lines. If we look along those lines, we're going to find an associated altitude. For example, this one here, they're calling for it to be 0 degrees Celsius at 12,000 feet along that bottom line. Well, follow the second line somewhere along here. They are being lazy on that one. There we finally see it. It's 0 degrees Celsius to 8,000. So you can basically see per line, it drops 4,000 feet. So in our area, we're expecting the freezing level to be somewhere between 5,000 and 6,000 feet. Therefore, departing the New Orleans area, it's going to be about 4,000 feet. By the time we get to Oklahoma, we're kind of following parallel to the freezing layer. It's probably going to be just about the same, somewhere between 4,000 and 5,000 feet. So therefore, certainly at 6,500 feet, I expect that basically if I'm flying in visible moisture, there's a certain potential for icing conditions. And by the way, these light purple shaded areas, which basically you can see we're inside the entire route of flight, that is an area where you can expect, again, icing conditions. Anywhere between, in this case, the purple box there, from 2,000 to 9,000 feet. So yeah, things are becoming more solid for me that this proposed altitude and route of flight, this time frame, is not looking so hot. And that's exactly the point of this very first section, is remember all of this falls under the big title, adverse conditions. It's going to tell you that things are already crud before you even really get into the full briefing. So you can already make a decision early on that this is probably just not a good idea, and I won't even continue further investigations as to whether or not I want to take this route. And therefore, I'm not going to look at notices to airmen or specific weather conditions. I'm already going to call no-go possibly. But let's say that we're still on the fence. We're going to continue on. To save time, I'm going to skip these additional Airmen Zulu updates for additional areas. We already know that, of course, there's some concerns in association. Now, there's also an airmet for turbulence. It's a low-altitude airmet, and we can see it's just about hitting our outskirts of our route of flight. According to our proposed arrival time, it looks like it sits just to the west of us, but that certainly means that this forecast could be inaccurate, and if the area speeds up, which based off my knowledge of what's causing this weather, it's apparently some fast-moving short waves aloft that we'll take a look at here in a little bit. They could certainly move into the area, and therefore we could also expect an airmet turbulent, airmet tango rather for, in this case, you can see turbulent, strong winds at the surface, specifically moderate turbulence and low-level wind shear. The summary, once again, airmet start, same time frame. It was created at the same time, 3:45 Eastern, Wind is still not identified or defined. Moderate turbulence, in this case, below 8,000 feet. So that's from the surface to 8,000 feet. Conditions continuing beyond 0300 Zulu to 0900 Zulu. And once again, they give us that red flag. You expect to possibly traverse this area for that portion of the flight at that time frame. Guess what? It follows that same format. It tells us who released it, what it's applicable for. So this one actually eats up into the Chicago Air Route Traffic Control Center. And then, of course, the expected conditions. So this is the AirMet Tango Update 3 for turbulent, strong winds and low-level wind shear until 0300 Zulu. They give us the boundary once again. Again, don't expect you to take out your chart and draw out the boundary from point to point to point. The graph does that for you, basically. Lastly, it calls for the conditions, which we already read in the summary, which is moderate turbulence below 8,000 feet, conditions continuing beyond 0300 to 0900. So we're seeing a consistent theme here. There's also an AirMet for turbulence for high altitude, all along our route of flight. But if we take a quick gander, you'll see that for us, that shouldn't be an issue, because high altitude, of course, in this case, you can see it's for moderate turbulence between flight level 180 and 420. So therefore, this shouldn't apply to us. All right, so we'll skip through all those. We get down, we finally get some good news. There's no AirMet for winds at the surface over 30 knots, nor is there an AirMet for low-level wind shear. Other types of weather products that could be included in the adverse conditions section would be adverse pilot reports. Urgent pilot reports. Those would be things like pilots reporting severe turbulence, severe icing not associated with thunderstorms or associated with thunderstorms. Low-level wind shear, where they're encountering a shift in their airspeed while on approach in excess of 10 knots. Things like that would be cause for urgent pilot reports. So there's no urgent pilot reports. There's no associated center weather advisories. There's no severe weather advisories, and there's no volcanic ash advisories, which I guess we would expect that should be the case. I am finding that this new next-gen thing does not work so well with an iPad. All right, there we go. So now that we know that we've got some adverse conditions, let's see what's going on big weather picture. And so sure enough, we can see that there is a frontal boundary moving into the area and associated with what's called a short wave, which is basically a high altitude disturbance. In this case, we can see there's an associated low pressure system, at least according to this weather product, which again, it's important to take a look at the valid time. So in this case, the valid time was 2100 Zulu. It is updated, however, at 2800 Zulu. So, sorry, 2228 Zulu. So what would that be local? We are 5 hours behind England. So if we subtract 5, this was updated at 528. Originally valid at 5 hours minus 2100 would put it at 1600 local, or 4 p.m. So at 4 p.m. they made this, and then they updated it at 528. Basically what's happening, I'll take a picture of this and I'll draw on it real quick. The winds aloft are blowing quite strong at high altitudes. I think there's some winds approaching 100 to 120, maybe even 130 knots. So it's blowing these systems off of the west coast and moving them actually quite rapidly from west to east. And so that short wave is creating enough advection, or I should say convection, lifting action, and an association bringing plenty of moisture that we expect those conditions that we saw associated with it, which would be low visibilities, low ceilings, certainly some possibility for precipitation and ice, snow, of course, depending on exactly where this system moves. The question is, where will the system move? One way to look at this, in addition to the current weather product, is to look at the forecast product charts from the 6, 12, 18-hour time frames, which we'll look at here in a second. This one, of course, is not just showing us our low pressure system. And bear in mind, of course, with the low pressure system, this is creating a counterclockwise flow, generally in association along these isobars. So remember, what are isobars in the first place? And if you don't know what they are, each little gray line represents a line of uniform pressure. In other words, if we follow this line here, we could say that somebody living on the border there, follow this line all the way up here to the opposite side of the country, they are both experiencing the same pressure. But more specifically, what we can see, of course, is when the isobars spread together closely, that means the pressure is changing rapidly from, say, here to here. And in association, there's lots of different concerns in association with that. Certainly stronger winds, and we can see that there's an air met tango for turbulence likely in accompaniment with that. But also, we can experience convective activity depending on the lifting action associated, and certainly, therefore, in this case, because of the wintry conditions, we can actually see that on the radar, we have mixed or ice conditions as opposed to liquid precipitation. And where is that in relation to our route? Well, not far from us. Our destination, of course, is in this area. We can also see some cloud formation with the satellite overlay as well. So sure enough, our weather producer, the cause for these conditions would be this shortwave producing this associated low pressure system. Remember that the area wind flow around this low pressure is generally just generally counterclockwise, but also inward towards the low. So certainly in association, we can see the flow would be pushing this direction in towards the low, but also from south to north, basically along those isobars. All right, so no doubt that our big weather producer is possibly going to create some widespread weather. So it's not just a localized condition. Before we go on, this thing is jumping all over the place. Let's just see what we expect the conditions to do as we progress. And just for time's sake, I'm going to jump over to ForeFlight and use a comparable weather product, but specifically going to look at a series of weather products. So we can see the same associated low pressure system there. This was valid at a previous time, however, not as more recent as what we just looked at. So if we press ahead, here is the 0600 Zulu forecast. So in this case, 0600 Zulu will be about 1 a.m. Certainly by 1 a.m., you've got widespread expected precipitation with rainfall in the light green and dark green areas with high likelihood. You've got a mix in the purple areas, and then you've got certainly some snow in the dark blue and light blue areas. And for sure, definitely covering our destination and some of our route of flight as well. So yes, that system is definitely pushing as we back up. That system is definitely pushing along from west to east, and therefore the conditions in conjunction. Okay. Excuse me. Now here's one of the deceiving aspects, of course, is that right now, just looking at the current METARs along our route of flight, everything's not too bad. Specifically, the green dots, of course, represent VFR conditions. And even in fact, many places where they have that open dot means that the skies are clear, as we can see based off of this legend here. That's, of course, where this can be deceitful, because just because the conditions are fine now doesn't mean that they're going to be in the near immediate future. But certainly, if we were just talking about from a trend standpoint, at least for now, our route of flight looks okay from that standpoint. Excuse me. Oh, by the way, I forgot to mention, if this will cooperate. I think if you're going to do this with an iPad, the best thing to do is to do the PDF. That's what I did last time, which worked just fine. So for future reference, if you're using this, definitely use the PDF version as opposed to the web-based version for now. You can see that, at least in this area, they include still an area forecast. I just wanted to mention that these area forecasts are no longer available for the contiguous United States. So these will only be included if it's just so happen chance that there's one of the few area forecasts left, namely the Gulf of Mexico and the Caribbean, where you so happen to be inside of that route. So just be aware that if you see that, sometimes it's only because of that particular condition. Okay, so far we can see at our departure, at least of course the current conditions at the Lakefront Airport in New Orleans. Good grief. VFR category, winds are from 040 at 13 knots, 10 statute miles visibility, clear skies, temperatures 9 degrees, dew points -5, altimeter is 3043. Looks fine. One airport along a route of flight in Lancaster, Texas. They've got ceilings of 7,000 feet or above. Lightning indicator remarks, I think they're talking about whether or not it can detect lightning. Destination, current conditions at Will Rogers World, Oklahoma City. You've got winds from 160 at 12 knots, 10 statute miles visibility. Ceiling is overcast at 16,000 feet. Temperatures 4, dew points -2, altimeter is 3025. Again, it looks pretty good. And the same would be the case at at least our planned possible alternate at this point. And of course, then from there, it's going to give you all the airports along your route of flight that we saw categorically before. My goodness. We're going to skip all these just for time's sakes so that we can focus on a couple of important elements. Here is where we're really going to see what is forecast-wise with our ceilings. These are particularly useful, and these are what's, by the way, the products that have now replaced our area forecasts. There's not a whole lot of information you can get on these as far as the Aviation Weather Services Handbook, which is one of the things I'm going to show you next. But it nonetheless is fairly straightforward, and it appears that they come out every 3 hours. This one specifically we can see is valid at 000 Zulu, so -5 for us would be 7 p.m. or -6 would be 6 p.m. in the Central Standard Time. We can see that, of course, there's a shaded area, and then they give us a legend at the bottom. In this case, if we've got gray areas, then it's a fewed scattered layer. If it's kind of a gray-blue color, a shaded blue, it's broken. And if it's kind of the indigo color, then it is overcast. And so there's this kind of thin layer, but in association, it just is calling for cirrus clouds. And what are cirrus clouds? They're high-altitude clouds. So they shouldn't be cause for concern. Overcast at 15,000, tops at flight level 440 in that area, but that's about it. However, this of course is already passed, so it does not apply. There we go. So let's jump ahead. This one is at 0300 Zulu, which would be closer to our planned departure time at 8 p.m. And as we can see, things look a whole lot different, so much so that you kind of lose track of where you are. So this is north of our route of flight into the Oklahoma area, and the clouds start to thicken up. Still calling for overcast at 1,500 feet with tops flight level 440. So that is a sign that there's some lifting action in association with those clouds. But at least according to this, there shouldn't be a base issue. But between that time frame and the next is really the question. Things appear to, that's not the right one. Where'd it go? Well, we've got a mistake. You can see here that for some reason we were reissued the previous forecast. So that's not going to work well for us. It went from 000 Zulu up to 0300 Zulu. This should actually be saying 0600 Zulu here. So we'll see if we can't find that in a different location. These you want to make particular use of. I'm about to scream. Tell you what, let's save ourselves a moment of frustration further, and let's go ahead and have this depicted to us in a PDF format real quick. With the PDF format, things look a little bit different, but we are not going to be dealing with that annoying scroll feature we were just dealing with there. So let's get back to where we were before. And maybe with this redissemination, they give us the correct forecast product. And it doesn't look like they did. So they jumped back to the 0 Zulu there. So we'll see if we can't find that here in a little bit. In the meantime, the associated weather product is also the visibility, surface winds, and precipitation forecast graphical depiction. So what this is going to show you basically is the conditions at the surface. Now there's quite a bit of going on, but the good news is we can see that there is a legend down in the bottom left-hand corner. So initially, this again is the forecast at 0 Zulu, so 7 p.m. local time for us, 6 p.m. there. We can see there's not much other than just simply the expected winds. So out of the New Orleans area, the winds are blowing out of the northeast. How do we know that? Because if we look, the long line represents the direction the wind's blowing from to the end point. In other words, if we choose this as our example, this is the point of reference, and the wind is coming from this direction blowing towards the end. So the winds are out of the northeast, therefore. The smaller barber pole lines, I call them, represent your speed. So since this one has a small line, not as long, for example, as this one, and it doesn't edge to the very stop, then that is a 5-knot marker. So you expect the winds to be out of the northeast at 5 knots. As opposed to off the coast, it'll still be out the northeast, but it'll accelerate to 15 knots. How do we know it's 15? Because the longer line represents 10, the shorter is 5, so that's 15, and then the red represents the gusts. So in other words, the winds would be out of the northeast at 15 knots, gusting to 20. Outside of that, with this initial forecast, we don't see much else going on until we get into the Oklahoma area, and then we see these dots representing rain specifically. The light green color means that there is a chance for rain, and if we look at the legend, you can see the light green color represents a chance of rain at 30 to 60%, as opposed to if it's dark green, it is likely, and therefore it's greater than 60%. Namely, the 2 dots represent continuous rain, and we're looking at somewhere between probably as little to moderate, maybe heavy rain, but more likely light to moderate rain. Let's jump to the 0600 Zulu forecast and see if they give that to us correctly. They did on this one. And so sure enough, we can see that what has happened. That system is pushed from west to east. Certainly we're expecting a high chance for rain, and even so, even worse conditions, we can see the winds pick up. On top of that, in the top, there's a potential for, in this case, snow, and even mixed snow. So it could be ice and snow. Due to that purple coloration, we can see that that represents the potential for a mixed precipitation. Lastly, the blue shaded area represents a reduction in visibility, in this case down to marginal conditions. How do we know that? Well, you can see that there. So in the visibility, the blue shaded area represents a visibility between 3 to 5 miles. And again, the purple represents a likely chance for a mix of snow and ice. So yeah, this is definitely giving us a good clear cut and dry sign that it's not looking like the best option to try to beat that system to Oklahoma. In other words, the sooner you leave, the better, but we're probably already off of our cutoff time at this point in time. It's just cutting it too close to call. Other alternate options, of course, would be considering flying up to close to where that system begins and then planning to land there, wait it out till it passes through, probably depart on through the next day. Okay, let's jump back down to where we were. And then we'll move on from there. So this is also particularly useful with terminal aerodrome forecast because we can see trend. We can see that once again, the green dotted areas represent forecast conditions to be VFR, but by the time we get to our destination, those conditions drop to the blue coloration representing marginal VFR. Namely, what do we expect the conditions to be like at our destination by the time we arrive? So let's scroll down to the last terminal aerodrome forecast. So this TAF is broken down in plain language. If you don't have practice in the undecoded version, I would recommend you do so. For time's sakes, we're just going to skip ahead and read this one. So we plan to depart at 7 p.m. local Central Standard Time. And in association with the 3-hour flight, therefore, we would expect that we would arrive at 10 p.m. So what time would that be in Zulu? Well, that'd be 200 Zulu plus 5 would put it at 1 a.m. So sure enough, the highlighted line that it gives us is the applicable time. So you can see temporarily between the 22nd rather of January at 0100 Zulu to 0400 Zulu, visibility is 4 statute miles, light rain and mist, ceiling is overcast at 2,500 feet. When it's not those conditions, because that's a temporary condition, then it'll be backing up to what it was previously, which is winds 150 at 13, gusting to 19. Visibility greater than 6 statute miles, and visibility and ceilings overcast at 12,000 feet. In other words, basically we're expecting rain showers to pass through the area or rain in association with this system. Kind of hit or miss. It looks like as time goes on, though, conditions go downhill. As then it goes from just always being marginal VFR to IFR to eventually low IFR. And then in case you can see in this specifically, you're dealing with light rain and snow and overcast ceiling somewhere between anywhere from 600 to 300 feet. So it's a no-brainer. The longer you wait, the worse things are going to get. So needed to leave basically sooner than what our planned departure time was, which would basically be now. Okay, that's about as far as I'm going to go in this. You can see that in the top of the PDF, there's 130 pages to go through. I'm just going to go through some of this stuff to show you once again that this can be quite intimidating as far as the amount of information. The key is knowing what's pertinent. The most pertinent thing, of course, to look at is that adverse weather conditions section, as well as adverse conditions in association with runway closures, airport closures, obviously, etc. But with time and experience, you can also learn to break down this additional information that could certainly affect your decision making as well. For now, let's jump back to one of the previous products we looked at, or we're about to look at, I should say. So last thing I want to take a look at before we jump over to our other route of flight is our winds aloft table. This winds aloft, of course, we can see this is a nice feature because it shows you kind of graphically what the winds aloft would be expected to be at different locations along your route. So we can see out of the New Orleans area winds, same thing about out of the northeast at 15. By the time you get to your destination, basically the opposite direction in association with that low pressure system where the winds are blowing out of the south to the north, where they're about 25 to 30 knots. But we can also see that textually depicted here. Over on the far left-hand side, you can see that there's a station ID, but also the applicable times. So in this case, the applicable times are depicted here. So this was created or valid at 0100 Zulu for the 22nd, but you can use it anywhere from 2000 Zulu, which would be, once again, -5 would be 3 p.m. local, or 1500 local, to 0300 Zulu, which would be about 10 p.m. Local here, or 9 p.m. in the Central Standard Time area. And then it gives you a bunch of stations, Oklahoma down to the New Orleans area through Dallas, Tulsa, For us, when we initially depart, we'd be looking at MSY, and they're saying at least at 6,500 feet, the wind should be 025 degrees at 16 knots. So sure enough, out of the northeast, by the time, once again, we get to the Oklahoma area, we can see the winds are out of the southwest, 203 degrees at 16 knots, and specifically in both cases, they give us a temperature. So sure enough, at 6,500 feet, we expect the temperature to be 0 degrees Celsius, as opposed to initially when we depart out of New Orleans, it's slightly above freezing. So once again, an additional confirmation that we expect our altitude to be at the freezing level. Now, when do I use what section? Because again, this is a bunch of information overload. The answer, of course, is it depends on when you're flying. Really, you don't care about these sections from here to here unless you're going to be planning to fly in those time frames. In other words, this one applies for if you're flying after 0300 Zulu to 1200 Zulu. This one would be applying, of course, if you're flying tomorrow morning, sometime between 1200 Zulu to 0100 Zulu. So I don't even care about these sections if I'm not going to be flying in that time frame, save for maybe just to simply see how the winds are shifting. But if I'm not truly concerned about that because I only plan to fly in this section, then I wouldn't pay attention to those winds unless, again, I'm cutting it close. And I, of course, let's see, 0300 Zulu certainly would be the case for us where we would look at both of these due to our planned flight time. Otherwise, if not, focus on the section that you're looking at. So in this case, if we're staying within this time frame, you don't need to allow this to create some type of cause for concern because it doesn't apply due to the fact that it's a different time frame. Okay, let's jump over to our other route. This one's going to be through ForeFlight. All right, so here's our route of flight. Again, departing the Nashville area and our destination. Again, for simplicity's sakes, we're just taking a look at the direct route to Asheville Regional. You can see, of course, that one of the concerns we have is the fact that we're going to be crossing the Smoky Mountains. So, of course, the ridges can be somewhere around 55 to 6,500 feet. Now, I obtained this briefing earlier in the day, specifically in the morning. So we're going to take a look at a situation where there's a little bit of a complication in routes, whereas, of course, the deceitful fact is the fact that the destination and the departure airports are both in VFR conditions. It's the en route that creates a complication. To start off, when we jump into this weather briefing, we can see that there are some adverse conditions in association with notices to airmen. So departing out of the airport that we're leaving from, we can see that there is a closure for runway 2 right, 20 left from the 21st of January at 1300 Zulu until 1800 Zulu on the 23rd of January. So if we're departing within that time frame, we'd expect that that's closed. Also, this runway seems to almost be nearly completely closed for, I don't know, a quarter of the year from January 7th until March 20th. Runway 1331's closed. So how many runways do they have left? Well, we'd have to take a look, but certainly this, of course, in conjunction with, say, winds, may be a cause for concern already off the bat. Our proposed departure time was in the morning, and in association, once again, we see the same weather products. We see an AirMet Sierra. Specifically, the black bounded area shows us our AirMet Sierra, not at our departure and not at our destination, but once again en route. And it shows where we would penetrate it based off of proposed departure time at 1200 Zulu, which would be a 7 a.m. departure Eastern Standard Time. We would fly through that area for basically about an hour. once again, a red flag to start off, specifically because if we look at the particular conditions, we can see that this isn't just an air met Sierra for IFR conditions. It's an air met Sierra for mountain obscuration. So that means that, of course, the ridges along the Smokies would be obscured by IFR conditions. Specifically, they're calling for mountains obscured by clouds, precipitation and mist, and the conditions expected to continue beyond 1500 Zulu, sometime in the ending between 1500 Zulu and 1800 Zulu. Well, we would already be in Asheville by that time frame. So we know that if we fly at this proposed departure time, there's no doubt that we'd be dealing with those conditions. There's also a secondary air met Sierra. In this case, same release time, but a different bounded area. Basically on the other side of the Smoky Mountains. Same conditions though, mountains obscured by clouds, precipitation, and mist. Conditions continuing beyond 1500 Zulu to 1800 Zulu. What can we already interpret based off of this? Well, in the opposite direction of what we just talked about, where the sooner we leave, the better off would be with the previous flight. This flight, it looks like the later we leave, the better off we would be. And we're going to see that in accompaniment because there's no large weather driver here. This is largely conditions that are being created based on the temperature overnight, which we'll talk about, i.e., in other words, radiation fog or upslope fog in conjunction with the temperature decrease overnight. There is, yep, sure enough, also an air met Zulu for icing. But we're going to jump ahead just to focus on the particulars here as well. There's also an air met Tango. So we can see those same exact weather products. However, the main focus we're going to look at is the surface analysis chart. Now, I have a hard time blowing this up, but basically, departing the Tennessee area, flying into the Carolina area, there's no large weather picture. So there's no real driving system in association with these conditions. So why do they exist? They exist because we simply have moisture in the area that, due to cooling overnight, has allowed that air to cool to its dew point. Now, what in the world are we talking about? Well, let's go back to some sources and see if we can't get some information about this. So once again, let's go to the Pilot's Handbook of Aeronautical Knowledge, look at the table of contents and see if we can't find anything in relationship specifically to fog in this case. Now, this time we're not looking at aviation weather services, we're looking at weather theory. So if we scroll down, let's look for some fog. Sure enough, we can see it, rather, a section on fog, 12-15. So let's jump to 12-15. And we can see a section on fog. Specifically, what you and I are talking about right now is particularly radiation fog. So what is radiation fog? Well, basically, overnight, as the sun goes down, of course, the ground is going to more rapidly cool than even the air above it. So as the ground cools, the air directly above it is going to radiate heat to the ground. So there's a heat exchange, and in association, as the air radiates heat to the ground, that air is going to cool. And if it cools enough, it will cool to its dew point temperature. And of course, if it cools to its dew point temperature, we get a formation of radiation fog. So with enough moisture, calm winds that don't mix this air about vertically or horizontally through this valley in this case, if that air is able to exchange enough heat to the ground, then it will cool itself to its dew point and we get visible moisture. So that's what we're dealing with. And so by knowing that, specifically in association with this particular condition, and comparing that to what we see on the air met Sierra for IFR conditions and mountain obscuration, if it's improving later on in the day, then we have confidence that as the air heats up somewhat, then we expect the conditions to improve. So really the question is, will it heat up or not? And that, of course, depends on, say, a cold front moving through or not moving through, or whether or not there's going to be enough heating from the sun etc. But we certainly have confidence based off the forecast from the AirMet, as well as what we know to be the case with weather theory, that we expect the conditions to improve. So if we're not going to cancel, then delaying is probably our best option going forward in this specific route of flight scenario. Sure enough, already from our get-go confirmation of our concerns, we can see at our departure, VFR conditions prevail. But we still have a bit of a concern with the fact that even though it's VFR, we still have an overcast layer at 3,100 feet. Now, going out to the practice area, that wouldn't be that big of a deal, but we've got to cross the Smoky Mountains. And if we take a look at the ridges once again, excuse me, along our route of flight, we can see there's a peak right there at 6,643 feet. There's another peak right there at 6,593 feet. Of course, this is MSL, not AGL, but nonetheless, where we're departing from, the fill elevation is only 600 feet. So if we add 3,100 feet to 600 feet, the clouds are basically at 3,700 feet MSL. So you can see starting out, if you had to stay low, you've got to find at some point the ability to climb higher, because you can't stay below that cloud layer unless it's well lifted above the mountains. And that's something, of course, that we'd want to investigate further. So let's take a look at what we expect the conditions to be like, say, in that area. So we can see some of the ridge areas there. So let's find this nearest marginal VFR condition airport. It's scrolling for me. There we go. So let's take a look at this one right here, KRKW. The last observation was at 11:55 Zulu, but sure enough, we've got a concern there that the clouds aren't getting better; they're actually getting lower, overcast at 2,600 feet. So we're getting a confirmation of the concern that we have. What's our only option other than that then? Because obviously we can't stay that low below the clouds and fly that close to some mountain ridges. Your only other option will be to climb above them. And what's the inherent danger of that? Of course, climbing above the layer, how do you know you're going to be able to get down below it? Not to mention the fact that your navigation is going to be restricted to where you're really truly dependent on radio navigation, not a whole lot of visual navigating going on, and then of course dead reckoning as well. That's a risky decision. So therefore, if you ever make that decision, you have to have the confidence that you're going to be able to get back down below it. But the problem, of course, is things really don't clear up. As we can see, for example, at Asheville, it's still overcast at 3,600 feet. So choosing to fly above the layer is also not the best option either. So once again, we're getting a confirmation that the best thing to do is to wait for the conditions to prove, or wait for weather products to come out to determine whether or not things are going to get better. Let's take a look to see if there's any pilot reports. There was a pilot report. In this case, let's look at the raw text. So the UA represents the fact that this is a standard pilot report. Then it gives you the location. So OV just simply represents over. In this case, they're over BNA at the 360-degree radial. That's your 360 there. And then the last three digits would be your distance. So they're 5 miles to the north, in other words, of BNA. Where in the world is BNA? Well, that's Nashville.
Dad, I want to watch the winter second because I want to watch both of it because I want to see the other winter because I haven't watched it.
Okay, thank you. No, you can't get on. Bye. Bye-bye.
Bye.
Bye.
No.
Okay, so we can see that there's an aircraft calling for some type of conditions basically directly to the north, but really over the Nashville area. Then it gives you the time. So it was 11:18 Zulu. It occurred during the climb, so they observed this during the climb. The type was a 737, so that may not apply to us, but then again, if they're probably at the same altitudes that we would be at, then we can interpret it as such. And yeah, it was observed that the clouds were overcast at 3,800 feet, tops are at 4,400 feet. So one more confirmation that there's definitely a solid overcast layer in the area, producing close to, if not certainly, marginal VFR conditions. We're going to use that same weather product that we were looking at before. And so if we zoom into the area, excuse me, there we can see not only that the cloud layer and the cloud conditions, but we can also see those air mets in association. Right now, it doesn't look too bad according to this at 7 a.m. We've got stations in the area reporting few at 3,000, few at 3,500 feet. However, as we cross the border between Tennessee and North Carolina, as well as South Carolina, kind of, it definitely thickens up along that border where you're getting an overcast at 3,000 feet and overcast at 6,000 feet. But if we jump ahead to, what was this at? 1,500 Zulu, we see things improve. We still have that air met for mountain obscuration in the light purple, but the clouds start to break up and clear up. And so certainly if we move even further to 1,800 Zulu, yeah, looking a lot better. No broken overcast coverage, few to scatter coverage in the area, like with 35 to 4,500 feet. So it is an additional confirmation that if we wait, conditions should improve, not deteriorate. Secondly, we also have the surface conditions. So you can see just to the north of our route of flight, they are calling for rain showers, snow showers rather. And let's see if that moves any further south, just as a reference of concern. It does not, so it stays to our north, basically. Certainly the conditions even deteriorate completely, or I should say dissipate completely, so that once again, the later you wait, overall, the better the situation would be. If you were on the fence, of course, taking a look at TAFs along your route of flight, by waiting later, once again, how long do I have to wait until the next TAF comes out? And in this case, we can see that, let's say that our concern is, for example, the KCSV airport. We can see that this was released on the 21st day of the month at 11:20 Zulu. How often do these come out? Well, once again, let's go back to our source. You could find this information in the POTS Handbook of Aeronautical Knowledge. You could also find this in the Aviation Weather Services Handbook. So this is kind of the ultimate glossary reference when it comes to any type of weather product. Goes well beyond even a lot of the things that we necessarily need to know. But if we wanted to go to the source, this is where this information comes from. In this case, we're looking not for an observation, we're looking for a forecast. So let's go to forecast and see if we can't find TAFs. There we see under 5.13 terminal aerodrome forecast. So we'll jump to that. And let's see if we can't find when these TAFs come out. So by the way, this can give you information about what TAFs are. One of the limitations we have, for example, with a TAF is the fact that it is limited to a 5 statute mile ring around the center of the airport, specifically the runway complex. So this is where, if you've heard that information before, this is the source where that information comes from. Specifically right now, we're just looking for one particular thing, which is how often do they come out? So you can see it gives us the different types of reports, gives us when they were broken down or denoted, the valid period, oftentimes a 24 or a 30-hour period. Then, of course, it gives you the breakdowns on all the different types of information that you get, the wind group, visibility group, significant weather conditions in association, all the different types of coding products you can see. So for example, a negative DZ would be light drizzle, followed by FG would be fog. Excuse me. And then of course they give you some examples, which are particularly useful
as far as looking at, say, a specific airport, and then an accompaniment, different types of weather conditions that you could see in accompaniment with that. But still, we'll scroll on to the particular that we're concerned with. And here's what we're looking for. So you can see that there are scheduled issuances basically once every 6 hours. So the answer is the TAF comes out once every 6 hours. Now, ours didn't come out at 1200 Zulu. It came out close to that. It came out at 1120 Zulu. But basically what that means is the next one wouldn't come out until, of course, close to about 1800 Zulu, somewhere around 17 to 1800 Zulu. Why do we care once again? That's another question that you'd be asked, because we want to, once again, know that you know how long you'd need to wait if you're on the fence and want to see what the new weather product is calling for. Okay, but once again, we can make a judgment based off of these combination of weather products that the longer that we wait into the afternoon, really, the better this route is going to look as far as a VFR flight goes, and certainly would be a better decision going forward. One last thing we want to take a look at was, would those runway closures at our departure, because there weren't any concerns at our destination, have an issue for us? So we're going to go to the airport. Oops, that's not what I want. I forgot the identity. That's what it is. All right, so we get the same advisory. Those are the two runway closures. If we take a look, we've actually got quite a few airport runways there. So you can see that it shouldn't be an issue. Once again, based off of the forecast conditions, let's go back and take a look at the expected conditions at our destination. So I'm going to skip all the way back. So at our prime departure time, we expect the winds to be 360 at 7. So no, we don't expect that even with those runway closures, there's still plenty of runways at this large airport that it should be a non-issue. So it wouldn't affect your decision making with that kind of wind and the runway orientation with the different runways we have available. That shouldn't be a complication. Okay. Let's jump ahead. One more thing to discuss before I let you guys go is remember that your departure and destination NOTAMs, of course, will be always included. But don't forget, when you start to get into weather briefing specifically, that you're going to start to feel some information overload when you get into the additionals. You've got a section on en route navigation NOTAMs. You've got a section on en route communication NOTAMs, service NOTAMs, airspace NOTAMs, all the different types of en route NOTAMs for any runway, taxiway, apron, aerodrome, or flight data center NOTAMs for any airport along your route of flight. So you can see as we scroll, we can start to feel that information overload. How do we break this information down is the key question to be answered. The first thing to know is that there are always going to be what we call D-NOTAMs or distant NOTAMs for your entire route of flight. Really what you always want to start off with is, like I said, starting off with making sure you understand your destination and your departure NOTAMs, but also your alternate NOTAMs. Those are the most key. Then from there, for now, as you first learn these weather briefings, you're going to work with your instructor to determine what's pertinent and what is not. Because a lot of these NOTAMs, for example, this one here, is pertinent to a heliport at a hospital for a departure procedure and association. That immediately tells us that this is an IFR procedure and doesn't apply. But until you know that, this is going to be some information that you're not sure Does it apply or not? This looks like mumbo jumbo to me. The key is start to ask these questions early on, and with enough experience and enough planning different scenarios, you're quickly going to be able to read through these and determine whether they're pertinent or not. So you can see that's the same for the second one, as well as the third one, etc. So we could spend 2 hours alone just looking at the notices to airmen together. Instead, the key takeaway is with enough repetition and discussion with your instructor, these are not going to take as long as they appear. And again, I scroll to kind of show that idea that, wow, do we really have to know all this? Well, believe it or not, with enough experience, you're going to know which one of these apply and which one they don't, which one of these they don't. All right. I am actually out of time. I was going to open it up for questions, but I actually have to get off pretty much now. So if you guys want to send me questions, please, you can either email me or send me a text. My phone number is 352-215-9546. You could also send me a message on here as well. I'll keep this open. And you can just send a chat link in the chat there, and I will respond most likely over email or a direct text message. Again, thanks everybody for joining us tonight. Again, if you have any questions, comments, please email them or send me a text at that phone number or otherwise on here.